So this question is evaluate root 2 plus 1 raised to 6 plus root 2 minus 1 raised to 6. Anybody? How to find its value? Any idea? Any idea? No.
Root 2 plus 1 whole raised to 6.
Yes. First of all, you just expand it. Root 2 plus 1 all raised to 6. You just expand it. There will be 7 terms. So I want to include all the terms in a single line. Okay. So first you have to expand root 2 plus 1 all raised to 6. You know that this is a plus b all raised to n. Understood. Starting with the a raised to n. If you cannot see, you can zoom it. The first term will be a raised to n. The second term onwards there will be coefficients. 6c1 root 2 raised to 6 becomes root 2 raised to 5 in the next term. Then 1 will come here extra. Then 6c2 will be the next coefficient. Let me complete this line. After that you can ask me doubt. Let me complete this line. Root 2 raised to 5 becomes root 2 raised to 4 next. Power will be decreasing. But 1 becomes 1 square in the next term. So after 6c2 you will get 6c3. After 6c2 the next coefficient will be 6c3. You can zoom, okay. Root 2 raised to 4 becomes root 2 raised to 3. I don't know whether I can include in this line. Root 2 raised to 3 into 1 square becomes 1 cube. After 6c3, next term will be 6c4, correct? Root 2 cube becomes root 2 square. You can zoom, okay. 1 cube becomes 1 raised to 4. Then 6c4, after 6c4 you will get 6c5. Root 2 square becomes root 2 raised to 1. 1 raised to 4 becomes 1 raised to 5. After 6c6, next term will be 6c6. The NCN will be the last term. Root 2 disappear and 1 raised to 5 becomes 1 raised to 6 at the end. All of it clear? You understood?
Yes.
Devasri Rakshana. Then all of you please remember, if you have once you have written the expansion of a plus b raised to n, it is very easy to write the expansion of a minus b raised to n, because a plus b raised to n and a minus b raised to n have the same term, but the problem is the sign changes alternately. In the case of a minus b raised to n, we get the exactly the same term, but the sign changes alternately. Alternately means plus minus plus minus plus minus, like that. So you just simply copy the expansion of root 2 plus 1 raised to 6. You will get root 2 minus 6, root 2 minus 1 raised to 6. Only thing is the sign to be changed alternately. So I will tell you. So below this I want to write the expansion of root 2 minus 1 raised to 6. The root a plus b raised to n and a minus b raised to n, both of them having the same terms. But in the case of a minus b raised to n, plus minus in that way. So you just copy the previous terms, and the sign to be changed. First I have the plus sign to be used, the second term minus. You just copy the same term. Okay. If you have written a plus b raised to n, you simply copy it. You will get a minus b raised to n. Only thing is sign to be changed alternately. Simply copy. Minus after minus plus. I am just copying it. Okay. After plus you will get minus. After minus plus. After plus minus. You can zoom, okay. I want to write all the terms in a single line. After minus plus. So a plus b raised to n and a minus b raised to n, both of them having the same terms. but sign here plus minus like that. Please note it. Okay, please note it. This step is clear. All of you clear this step?
Yes, sir.
Rakshana, have you understood? Rakshana,
Yes, sir.
who is this? Nadia.
Stage, sir.
Okay. So the both the expansion I have written. What is our question? Root 2 plus 1 raised to 6 plus root 2 minus 1 raised to 6. So we have to add them. We have to add. If you add left side, what happens? If you add left side, you will get root 2 plus 1 raised to 6 plus root 2 minus 1 raised to 6. If you add right side, some terms cancels. Which terms cancel? Can you suggest? The terms this one cancel. Just like plus 7, for example, plus 10 minus 10 cancel. In the same way, this one and this one are same but opposite in sign. This term and this term are identical but opposite in sign. So if you add first equation and second equation, these two cancels. Similarly, plus and minus cancels. Here also plus minus cancels. Other terms will be 2 times. Why 2 times? Root 2 raised to 6 plus root 2 raised to 6. 2 times root 2 raised to 6, right? For other terms, there will be 2 times. I mean, this one plus same term. Understood? This term plus same term. There will be 2 times. So for the rest of the terms, there will be 2 times. You can take 2 outside. Let me complete this line. After that, you can ask me doubts. If you add the remaining terms, you will get 2 times. 2 is common. So root 2 raised to 6 plus root 2 raised to 6, 2 times root 2 raised to 6. 2 is taken out. 62 root 2 raised to 4. 1 square will be 1. I don't care. 1. Okay. 62 root 2 raised to 4 plus 62 root 2 raised to 4. 2 times 62 root 2 raised to 4. You need not care about 1 raised to. Okay. 1 raised to always 1. Here also 64 root 2 square plus 64 root 2 square. Again 2 times. 64 root 2 square. Let me complete this line. After that, you can ask me doubt. Okay. Okay. Is my voice audible? Is my voice audible?
Yes, sir.
Okay.
Yes, sir.
Okay. Finally, 1 raised to I don't care. 66 plus 66, right? 66 plus 66, 2 times 66. 2 is already taken out. Okay. Till this step, all of you please write down till this step. Okay. All of you please write down till this step. If you have any doubt, you please ask me. If you have written, understood, raise your hand. ശിവാനി കഴിഞ്ഞു അല്ലേ? ഓക്കെ. ശിവാനിക്ക് ഇതിൻ്റെ ആൻസർ കിട്ടിയാൽ പറയണേ.
Sir, 198 എന്ന് ആൻസർ കിട്ടും.
198 കിട്ടിയല്ലോ. ഓക്കെ. ഓക്കെ. എന്നാൽ ശിവാനി ഞാൻ വേറൊരു ക്വസ്റ്റ്യൻ തരാം. ടെക്സ്റ്റ് ബുക്ക് ഉണ്ടോ കയ്യിൽ?
ഉണ്ട് സർ.
ഓക്കെ. എനിക്ക് ഇനി ചെയ്തിട്ട് ആൻസർ അയച്ചായിരുന്നേ. ഞാൻ ടെക്സ്റ്റ് ബുക്ക് കാണിച്ചു തരാം. ടെക്സ്റ്റ് ബുക്കിൽ മെത്തേഡ് അവർ സ്പെസിഫൈ ചെയ്തിട്ടുണ്ടാവും. അത് നോക്കണ്ട കേട്ടല്ലോ. 11th ക്വസ്റ്റ്യൻ ചെയ്യണം കേട്ടോ. 11th വൺ.
ഓക്കേ സർ.
ആൻസർ എനിക്ക് അയച്ചായിരുന്നേ. നോക്കാം. രക്ഷണ ഫിനിഷ്, സയ്യിദ് ഫിനിഷ്ഡ്. ദേവശ്രീ യു ആർ റൈറ്റിംഗ്?
Yes, sir. 1 minute.
Okay. I will discuss extra problems. Okay. By today's class, I will finish this chapter, binomial theorem.
Completed.
Completed. Okay, okay. Root 2 raised to 6, how will you find its value? Root 2 raised to 6. Anybody? Root 2 raised to 6, how will you find its value? Don't know? Root 2 is 2 raised to half, right? Root 2, I will show the steps here, okay? In the right side. I want root 2 raised to 6. Understood? Root 2 raised to 6 is 2 raised to half raised to 6. Rough calculation I will show in the right side. Root 2 is 2 raised to half. You know that. So 2 raised to half raised to 6. The power to be multiplied. 1 by 2 into 6. Rakshana, if you don't understand, you please ask me. 1 by 2 into 6 will be 3. Correct? All the rough calculation you can write in the right side. Root 2 raised to 6 I want. 2 raised to half raised to 6. 2 cube 8. So this one is 8. Now 62 is the required. I have already discussed how will you find 62? 6 into 5 divided by 1 into 2 or 2 into 1. If you don't remember, you can ask me after writing this step. After completing this slide. 62 is 6 into 5 by 2 into 1. Root 2 raised to 4. I will show the rough calculation here. Root 2 raised to 4 is, root 2 is 2 raised to half. Root 2 is 2 raised to half. The power is multiplied 2 square. 4. 64. A rough calculation can be written here. In the previous class, in the chapter permutation combination, I discussed that NCR equal to NC n minus R. In the chapter permutation combination, I discussed. In the case of NCR, if n and r are adjacent, if n and r is adjacent, we can use the property that NCR equal to NC n minus r. 6 minus 4 is 2. If n and r are adjacent, NCR equal to NC n minus r. So 64 is same as 62. 62, you know, I have already explained. 6 into 5 by 2 into 1. Root 2 square, you know that it is 2. NCN is 1. We have a property that NCN is 1. There is a property. So 66 is 1. Okay, I hope you have understood. So let me write the final answer. After that you can ask me doubt. 2 into 8 plus, here simplification, 60 plus, is it correct? Yes, here what happens, 30 plus 1, 91, 198, 99, 99 into 2, 198 is the answer. I will discuss one more question similar to this. All of you please write down. If you don't understand any step, please ask me. If you don't understand, please ask me. If you have written, raise your hand. If you have written and no doubt, raise your hand. Rakshana, okay, understood. Devasri, clear. Shivani, അതിൻ്റെ ആൻസർ ഒന്ന് അയച്ചേരണം കേട്ടോ.
Okay, sir.
സെയ്ദിന് എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടോ? സെയ്ദ്,
No, sir. No, sir. No, no.
completed? No, Seyd.
Yes, sir.
Finished. Let me discuss one question outside NCRT. I want to discuss one more question similar to this. Okay. Find 3 plus root 2. not difficult. I want to discuss one more question. 3 minus root 2 raised to 4 using binomial theorem. Okay, this is the question. 3 plus root 2 raised to 4 plus 3 minus root 2 raised to 4. So solution is the expansion, 3 plus root 2 raised to 4, a plus b raised to n. You know that a plus b raised to n starting with a raised to n. A plus b raised to n start with a raised to n. Then coefficient appears NC1, 4C1. The power of 3 will be decreased by 1. 3 raised to 4 becomes 3 cube. But root 2, the root 2 will come here. After 4C1, next coefficient is 4C2. 3 cube. ശിവാനി അയച്ചോന്നല്ലേ, ഞാൻ നോക്കാം കേട്ടോ. ഈ ശിവാനി ഇതും കൂടി ചെയ്യട്ടെ, ഇത് വേറെ ക്വസ്റ്റ്യൻ ആണ്. 3 cube becomes 3 square. 3 cube becomes 3 square. Root 2 becomes root 2 square. 4C2, after 4C2 you will get 4C3. 3 square becomes 3 raised to 1 and root 2 cube. After 4C3 you will get 4C4. NCN will be the last term. 3 disappear. Root 2 cube becomes root 2 raised to 4. This will be the last term. A plus b raised to n and a minus b raised to n, both of them having the same expansion. But in the case of a minus b raised to n, the term will be plus minus etc. So you simply copy the previous terms. Simply copy the previous term. The sign to be changed. First term plus, the second term minus. Same term. After minus plus, you simply copy. Okay, 4C2 3 square into root 2 square. After plus minus. After minus plus. Okay, I hope you have understood. It's very similar to the previous question. I got two equations. I have to add them. So 3 plus root 2 raised to 4, left side is added. Till this step, do you have any doubt? Rakshana, Devasri, Said, do you have any doubt till this step?
No, sir.
Devasri, you understood? Devasri?
Yes, sir.
So left side is added, so right side to be added. Like previous question. These two terms cancel. Equal in magnitude, opposite in sign, cancel. You need not write it again. Other terms will be 2 times. Like 3 raised to 4 plus 3 raised to 4, 2 times. Here also 2 times, here also 2 times. 2 is common, take outside. 3 raised to 4 plus 3 raised to 4, 2 times 3 raised to 4. 2 is taken outside. 4C2 into this plus 4C2 into this, 2 times. 4C2 3 square into root 2 square. 4C4 into this plus 4C4 into this, 2 times. 2 is taken out. 4C4 root 2 raised to 4. So you will get 1 minute. 2 into 3 raised to 4, 3 into 3 into 3 into 3. I don't want to discuss that. 4C2 is 4 into 3 divided by 2 into 1. If you don't understand, please tell me. 3 square is 9. Root 2 square is 2. 4C4 is 1 because NCN is 1. Root 2 raised to 4, I have already explained that. Root 2 raised to 4. Rough calculation will be written in the right side. Root 2 raised to 4 is 2 raised to half raised to 4. 2 raised to half raised to 4. The powers to be multiplied 4. 4C4 is 1, you know that, because NCN is 1. Root 2 raised to 4 is 4. ശിവാനി കഴിഞ്ഞിരിക്കുകയായിരിക്കും അല്ലേ? So what happens next? 2 cancels. What is the answer? 2 into 81 plus, what is this? 12 into 9, 1 minute. 108 plus 4. Let me add it. 108 plus 85. 193 into 2. 386. Answer is 386. So all of you please write down. So if you don't understand any step, please ask. If you have written and clear, raise your hand. Devasri, Shivani, okay. Say the clear. Say the understood, finished, okay. Next is, let me discuss question number 13. I will finish this chapter by today. Question number 13 I am going to discuss. Show that 9 raised to n plus 1 minus 8n minus 9 is divisible by 64. How to do this question? Any idea? 9 raised to n plus 1. Do you have any idea? If you have any idea, please tell me. Where n is a positive integer, natural number. The question is 9 raised to n plus 1, where n can be any natural number. Minus 8n minus 9. By simply putting n equal to 2, n equal to 3, that is not the proof. Understood? If you put n equal to 2 or n equal to 3, if it is proved, that is not the general proof. We have to prove that it is true for all natural numbers. We have to prove that it is true for all natural number n. How can we prove it? Is there any scope for using binomial theorem here? Yes, I will tell you. There are two ways. Raised to n is okay, but raised to n plus 1 is confusing. Let me do one thing. 9 raised to n plus 1. Can I write 9 raised to n plus 1 as 9 into 9 raised to n? 9 into 9 raised to n will be understood. 9 into 9 raised to n will be 9 raised to n plus 1. I want the power n. I want the power n. That is why. Is that okay? This first step is clear to you? Please respond. The first step is clear?
Yes, sir.
Okay, in the next step. ശിവാനിക്ക് അറിയോ ഈ ക്വസ്റ്റ്യൻ? ശിവാനി ചെയ്തിട്ടുണ്ടോ?
ഇല്ല സർ.
ഇല്ല. So 9 raised to 1, 9. Okay. Can I use binomial theorem? Currently no. For binomial theorem I want a plus b raised to n. But I can do one thing. Can I write 9 as 1 plus 8 or 8 plus 1? Yes. I can write 9 as 1 plus 1 minute. Yes. 9 can be written as 1 plus 8 raised to n minus 8n minus 9. Why I am writing 9 as 1 plus 8? Then only I can use the binomial theorem, a plus b raised to n. Using binomial theorem, I am verifying that the entire expression is divisible by 64. Whatever may be the value of n. 9 into, let me expand it, a plus b raised to n. Is that okay? This is of the form a plus b raised to n. A plus b raised to n start with a raised to n. meaning that 1 raised to n. Remember, 1 raised to anything will be 1, but I will write in the next step. Okay, I don't want to skip any step. A plus b raised to n start with a raised to n, then nc1 coefficient will come. 1 raised to n becomes 1 raised to n minus 1 because the power will be reduced by 1. B come here 8. In the next step I will not consider 1 raised to. 1 raised to is 1. I will not consider in the next step. nc1, after nc1 you will get nc2. The power of 1 again reduced by 1. 1 raised to n minus 2. 8 becomes 8 square. Let me write one more term. After nc2 there will be nc3. The power of 1 again reduced by 1, n minus 3. But 8 square becomes 8 cube next. Understood? Etc. Then you can see that higher powers of 8 will come here. This term onwards, the higher powers of 8 will come. 8 cube, 8 raised to 4, like that. In this way, what will be the last term? The last term will be, I don't want to write all the step. First term a raised to n, last term b raised to n. Thing like that. Understood? Or NCN. NCN will be the last coefficient. If I write in this pattern, NCN will be the last coefficient. 8 raised to n will be the last term. First term a raised to n, last term b raised to n. Minus 8n, minus 9 outside. Okay, minus 8n, minus 9 outside. Let me write one more step. After that, you can ask me doubt. Okay, let me write one more step. One more step. So 9 into, let me write here. 1 raised to, you can avoid 1 raised to. You need not take a, you need not consider 1 raised to. 1 raised to will be always 1. And 1 into any number is the same number. Okay. So here 1 raised to n is there. It is 1. NC1. We have studied the property in the chapter permutation combination. You have studied that NC1 is n. In which chapter? Permutation combination you have written. NC1 is n. NC1 means one objects to be selected from n objects. If you don't remember that property, think like this. NC1 means in how many ways one object can be selected from n objects. N ways you can select. You have written it as a property. NC1 is n. 1 raised to, I don't want to consider, into 8. N into 8. Or 8n. Then next term NC2. I don't want to write the value. 1 raised to, I am not considering. Then NC3. 1 raised to, I am not writing. NCN will be 1. It is another property. NCN is 1. Outside minus 8 and minus 9. All of you please write till this step. All of you please write till this step. If you don't understand any step, please ask. If you have written all the step and no doubt, raise your hand. Say the understood. Shiva, any okay? Devasri Rakshana, have you understood? Devasri Rakshana?
Yes, sir.
Yes, sir.
In the next step, I will give you one similar question. Okay, you need practice. Can I open the bracket here? I can open the bracket. 9 into 1 will be there. Understood? If I open the bracket, 9 into 1. 9 into 1 will be 9. I am opening the bracket. 9 into 8, 10. 9 into 8, 10. 9 into 8 is 72. So 9 into 18 will be 72n. Is that okay? Then higher powers of 8 square. I mean higher powers of 8. Like NC2, oh, sorry, 9 to be taken inside the bracket. Okay, okay, okay. 9 to be taken inside the bracket. Okay, let me take it. NC2 8 square. 9 into NC3 8 cube. Higher powers of 8. 9 into 8 raised to n at the end. Then minus 8n. 8n minus 9 after that. What I have done in this step, I just open the bracket. I just open the bracket. Understood? One term cancel. One term cancelled. Which one? 9 plus 9 and minus 9 cancelled. Okay. And look here. 72n is there. Minus 8n is there. They are similar terms. You agree with me? 72n minus 8n. 72 minus 8 is 64. 72 minus 8 is 64. So this minus this will be 64n. Then 9 into NC2 into 8 square. 8 square is 64, right? 8 square is 64. You know that. Okay. 9 into NC3 8 cube, etc. 9 into 8 raised to n. In the next step you will get the answer. You can see that 64 is I mean this entire term is divisible by 64 because 64 is present in every term. The first term is divisible by 64. You agree with me? First term, I mean 64 is common. That is the right way. The first term contains 64. You agree with me? Second term contains 64. 8 square is 64, right? First term contains 64. The second term contains 64. 8 square. Third term contains 64. Because 8 cube is 8 square into 8. 8 cube is 8 square into 8. So third term contains 64. So you can take 64 common. You can no need to write any further step. You can write this. Let it be the last step. 64 into some natural number. What is the reason? Because 64 is common in every term. We can take 64 outside. If you take 64 outside, the remaining will be some natural number. NC2, NC3, etc. will be some natural number. 64 can be taken outside. So 64 into the remaining term will be the some natural number. So what is my conclusion? My conclusion is this 9 raised to n plus 1 minus 8n minus 9 is a multiple of 64. This one is multiple of 64. Hence 9 raised to n plus 1 minus 8n minus 9 is divisible by 64. Why it is divisible by 64? Because this number is a multiple of 64. Hence it is divisible by 64. So all of you please write down. You can ask me doubt. It is a tough question. You can ask me doubt. If you have written clear, raise your hand. I will give you one similar question right now. Okay. Devasri, Rakshana, Said. Everyone okay? Clear?
Yes, sir.
Yes, sir.
Then let me give you one similar question. You have to send me the answer within 2 minutes. Try, okay? Similar question. I am giving you similar question. Show that. It is very easy compared to previous term. Try it. The first step will be 7 can be written as 1 plus 6. Okay, the first step only I will tell you. 7 can be written as 1 plus 6. Do it. Within 2 minutes you have to try to finish it. Send me the solution through WhatsApp. ശിവാനി കിട്ടുന്നുണ്ടോ? കിട്ടിയോ? ആ ഓക്കെ ഓക്കെ. Devasri, are you able to solve this question? Devasri?
Sir, doing so.
Doing, okay. Next is, so the 14th one I will discuss. 14th one is appear to be tough, but it is very simple question. 14th question. The sigma simply means summation, okay? Sigma simply represents the summation. Rakshana, say that you must send me the solution, okay? This question, the solution of this question. If you are not getting it, please tell me, okay? I will send the solution. So,
Okay, sir.
look at this question, sigma. Our question is sigma. Sigma means summation. Sigma r equal to 0 to n, 3 raised to r NCR. We have to prove that it is 4 raised to n. This is not tough question. It is a very simple question. First of all, you have to understand the meaning of the sigma. This is said to be sigma. Sigma means summation. Initially, we are putting r equal to 0. Initially, we are substituting r equal to 0 plus, next we will put r equal to 1 plus r equal to 2, etc. Finally, we put r equal to n. This is the initial value of r, 0. N is the final value of r. So, what is the step? Initially, you have to put r equal to 0 in this expression. Let me write the first step, first line let me complete. After that you can ask me doubt. Initially you have to put r equal to 0. So substituting r equal to 0. You will get this term. I am putting r equal to 0 initially. Sigma means summation, right? Plus. After r equal to 0, the next value will be r equal to 1. Substituting r equal to 1. 3 raised to 1 NC1. I just put r equal to 1. The next value of r is 2. 3 square NC2. Next I will put r equal to 3. In this way I will proceed. Finally I will substitute the value r equal to n. R equal to n, you will get 3 raised to n NCN. The meaning of the sigma is okay, clear. Initially put r equal to 0. 0 is the initial value of r. Then r equal to 1, r equal to 2. Finally r equal to n. All of it clear? Devasri, Rakshana, Said, Shivani, everyone is okay?
Yes, sir.
Rakshana understood. So, does it look like a binomial expansion? I will do one thing. NC0 is 1. NC0 is what? It is 1. 3 raised to 0 also 1. The first term, let it be 1 itself. NC0 1. We have studied it as a property. In the previous chapter, you have written that. NC0 1. There is a property. 3 raised to 0 is also 1. First term 1. Second term, let me change the order. NC1 into 3 raised to 1. Can I write like that? NC1 into 3 raised to 1. Changing the order is not a problem. Next term NC2 into 3 square. NC3 into 3 raised to 3. Finally NCN into 3 raised to n. Very similar to the binomial expansion. No need to write more steps. The starting term is 1. Can I write 1 as 1 raised to n? Is there any mistake? If I write the first term 1 as 1 raised to n, no mistake. Look at this entire expansion. The first term is 1 raised to n and last term is 3 raised to n. Have you the remaining term? I don't want to, for the time being, I don't want to look at the remaining term. First term is 1 raised to n, last term is 3 raised to n. There is a good chance that it is the expansion of 1 plus 3 raised to n. Yes, you can check it. If you expand 1 plus 3 raised to n, you will get all these terms. First term 1 raised to n, then NC1 will come, then 1 raised to n minus 1 will be there. 1 raised to n minus 1, I don't want to care. Okay. Into 3. So it is clear that it is the expansion of 1 plus 3 raised to n. First term 1 raised to n, last term 3 raised to n. So clearly it is the expansion of 1 plus 3 all raised to n. So 4 raised to n. No need to write more steps. Okay. So this is LHS. I got RHS. Okay. All of you please write down. If you have understood and written, raise your hand. If you don't understand, you please ask me. Devasri, you must ask me doubt. Okay?
Okay, sir.
All of you are finished. Shivani complete ആണ് അല്ലേ Shivani?
Yes, sir.
Okay, I can discuss one more question. The miscellaneous I will discuss later. Okay, during the time revision time I will discuss more difficult questions. Let me discuss question number 10. Let me discuss question number 10. You read the question, try to understand. Question is, using binomial theorem indicate which number is larger. 1.1 raised to, what is this, 10,000. 1.1 raised to 10,000 or 1000, which one is larger? That is a question. Appear to be tough, but not it is not tough. I will discuss. We cannot find 1.1 raised to 10,000. 1.1 raised to 10,000 is 1.1 into 1.1 into 1.1. 10,000 times we have to multiply. Even using calculator, we cannot do it. It's very difficult to find out. So we have to check which one is larger. So look at the 1.1 raised to 10,000. All of you please listen. We have a 1.1 raised to 1000. Sorry, 10,000. 10,000. Let me use binomial theorem. 1.1 is 1 plus 0.1. Can I write like that? 1 plus 0.1 raised to 10,000. All of it clear? This step is okay? Please respond. Devasri, Rakshana. Okay. This is the expansion of a plus b raised to n. This is the expansion of, we can use the expansion of a plus b raised to n. First term will be 1 raised to 10,000. Initially, let me write important steps. A raised to n will be 1 raised to 10,000. Then NC1, NC2 like that. NC1 will be 10,000 C1. That will be NC1. The power of 1 will be reduced by 1. 1 raised to something 1. You need not write it. Okay. 1 raised to 10,000, understood. 10,000 minus 1 will be, okay, you may write it 9, 9, 9, 9. The power of 1 is decreased by 1. At the same time, the 0.1 will come here, okay. Then let me write one more term. 10,000 C2, the power of 1 again decreases by 1. 9, 9, 9, 8. The other term will be 0.1 square. Then other terms, etc. Okay, no need to write all the terms. Finally, b raised to n. Understood. Or 10,000 C, 10,000 is 1. Finally, 0.1 raised to 10,000. We need not write more terms. The first term a raised to n, last term b raised to n. Okay. This is the expansion of 1 plus 0.1 raised to 10,000. All of it clear? Till this step you are okay? Till this step you are okay?
Yes, sir. Yes, sir.
Now, look here. 1 raised to 10,000. 1 raised to anything will be 1. 1 raised to anything will be 1. Here 10,000 C1. You know that NC1 is n. We have a property. We have a property that NC1 is n. So 10,000 C1 will be 10,000. 1 raised to any number will be 1. I don't care this 1 raised to. Okay, leave it. 0.1 is there. Then the remaining terms I don't know. The remaining terms are some positive number. I don't know the value. Okay, plus some positive number. I don't know the value of the remaining term. Let me write some positive number, because it is very difficult to evaluate. This term onwards, it's very difficult to evaluate. Some positive terms. Let me write like that. First term and second term I can easily write. The remaining term is very difficult to find out. So let me write some positive term. Positive number. The remaining numbers are not negative. Some positive number. Value I don't know. 1 plus, what is this 10,000 into 0.1? What is this? Tell me. 10,000 into 0.1 is what? No response. 10,000 into 0.1?
1,000.
1,000. 1,000. Plus some positive number. So 1,000 plus 1 will be 1,001. Plus some positive number. Clearly it is greater than, without any doubt you can write, it is clearly greater than 1,000. What is our question? Which is larger? 1.1 raised to 10,000 or 1,000? Which one is larger? I got 1.1 raised to 10,000 as 1.1 raised to 10,000 as 1,001 plus some positive number. That I don't know. Whatever may be this some positive number, 1,001 plus some positive number will be clearly greater than 1,000. There is no doubt. So which one is larger? The larger number is 1.1 raised to 10,000. This is the larger number. So all type of questions I discussed from this chapter. The miscellaneous and difficult question I will discuss later. Okay, all of it clear? So all of you please write down. All of you please write down. If you have written and 100% clear, then you may leave the meeting. If you don't understand any step, please ask. If you have written, you may leave the meeting. Okay.